Yo, what's up, everybody? Welcome back. Today we are working on our collaborative Rube Goldberg machine. So the context for this project is we're working on like these like physics simulations, right? So I hit reset here. These balls are bouncing around, and like the semi interesting part about this project is that these environments that we're seeing right now are completely defined by WebAssembly modules, right? So these platforms are moving back and forth. When a ball collides with the platform, we are actually calling into a WebAssembly module, and the WebAssembly module is saying like, hey, I have a platform here, and I am going to apply this physics response to the balls. Actually, technically, he doesn't tell the server that he has a platform there. He just tells the server that he wants to apply a physics impulse to the ball. Then that same WebAssembly module is passed over to the client, and we serialize the state from the WebAssembly module from the server. We send it up to the client, and we say, "Hey, WebAssembly module, could you draw this?" And he draws the platforms, right? And what this should enable is it should enable the ability for us to have like a pretty giant machine where like we have like a series of chambers, and each of these chambers can have like super custom code, right? So you could imagine like maybe one has like a bucket of water and the balls float in the water, and every once in a while like somebody flushes the toilet and all the balls like get pulled out with the water into the chamber below. And then maybe in this one you have like a planet that has like really dense mass, and like the balls will like orbit around this planet and get like flung out to the next one. Maybe in this one you have like a portal, and like balls go into the portal and they get like fired out of a portal over here, right? Maybe you have one where you're simulating a game of pong in zero gravity, and these paddles try to catch up to the balls that are coming to them, and if they miss, they get locked out, right? All sorts of custom behavior, right? And the idea is that because these things are WebAssembly modules, we can be pretty confident in like the sandboxing of these things, and we can allow users to just upload modules. And so that's what we've been working on. So last stream, or maybe 2 streams ago, I can't remember, we added this like upload page, right? And so now when I click on this, I can say, hey, I have like a super simple module, I want to submit it, and now we have like this third thing down here, right? And which is really good because it means that we have like persistence. This gets stored in the database. If I stop the server and restart it, like that, these chambers are still there. But what kind of sucks is we've lost some of the like testing workflow for developing a chamber itself. Because before we used to pass the chambers directly on the command line, and when you were doing like your edit compile loop, you would just restart the server pointing to a chamber. We don't have that anymore because chambers are tied to the database because of like some choices that we made. And so today I kind of want to work on like just chamber development quality of life. So I think that there's a couple things that we can do here. One is that we can like, why am I doing this in fucking Paint? What am I doing? One is like we can enable like complete client side testing, right? So the idea there would be somebody develops a module and there's like a testing page here, and they just say, I would like to test this module, and you have like the simulation of the balls jumping around that is currently only on the server. You could do a client-side simulation of that, and then you would get a feel for what will happen when the simulation gets actually uploaded, right? Another thing that I want to work on is debuggability. So right now, if something is going wrong in your WebAssembly module, like we give the module a way to like print to the screen, but it's kind of like bad. Like the API is like log s and slen, and we just kind of like print that thing out. And so if you want to do something like print number, you have to like create something that like allocates a buffer, does like string to int or int to string, and then like push that into the log function. It kind of sucks. So I want to basically have the ability for chambers or wasm right now, right? When we do client-side testing, we're also going to have to implement like some sort of like non-wasm interface, so that we can call into the browser like and ask it to interact with the chambers, right? Because if our simulation is running on the server, we can't like load a wasm module from a wasm module. We're going to have to talk to the browser, and so this is going to turn into some sort of like client interface. And with that client interface, we can do something like load shared objects instead of WASM modules, and that will allow us to basically run GDB and have like all of the printing statements you would normally have. You could like do your initial development as local to your machine with shared objects, then work your way towards doing whatever the fuck we were talking about, WASM chambers later. That's kind of the idea, and so this is what we want to work on today. So the plan of action is approximately figure out how to get like the simulation that's currently server-side only working on the client. So we're going to compile Zig to WebAssembly, instantiate it on the browser, run the physics simulation on the balls, add some glue code for like interacting with the chamber from JavaScript. So right now we have our simulation. He kind of does this stuff where he says like, I'm going to do some stuff with the balls. right? I'm going to apply gravity, I'm going to clamp the speed, I'm going to apply velocity, I'm going to like wrap the balls around from the chamber, like based off like if they go at the chamber bounds. Then I call into like the chamber and I do like a physics step, and then I apply collisions and stuff. So we kind of want like this thing to be extracted, but we kind of want all of this to still run. And so we're gonna have to add some sort of glue code to basically say, like chamber interface step, right? And this will do one of three things. It'll do wasm time step. It'll do fire like browser step, or what was the other one? Shared object step. Right? So we're basically gonna have to like implement this thing. And so the second step of this thing will be implementing this like browser step API. Then we are going to have like we're gonna have to like make a page for testing client side in the browser. And if we get through all of that, then we can start working on like the shared object side of things. But we'll see how far we get. Because I can't go too far over today. I have like some other things I have to do after 4 o'clock, but we'll see how far I get. Okay, so we're 6 minutes into stream. And compile entire simulation to WebAssembly module. Okay, so this simulation, he has like some things in him that are not really related to like the ball simulation part. He has like, some like mutex locking and stuff. That doesn't really belong in here anymore, because this is like we're running like a server. The server's calling into the simulation. He needs to lock the mutex to make sure that there's no like contention on resources. So this stuff doesn't really need to be here. All of this still does, like all of the physics simulations for the balls, we're still going to want to do those client side. So this stuff stays in, like collision handling. And then we also have this like concept of like writing down the history, so that we can like basically replay a simulation later for testing. It does seem like this will be a useful concept on the client side as well, because you could imagine that as our client side interface, like you're testing your chamber has some physics bug, and you like spot the physics bug. I think being able to save the history and then replay it will be very useful, because that's kind of why it exists in the first place. And so I think that we will probably keep this as well. Which kind of means that like most of this stuff stays. This random number generator, I think, is for when you reset the simulation. We basically like instantiate the balls in random positions. So this can stay. This chamber mod will have to basically be turned into some interface, I think. I was considering doing it the other way, right? There's kind of two options here. One is that you could have a simulation takes, how do you draw this UML diagram? I think it's a diamond. He has a reference to like chamber, right? And when he wants, then he does like his stuff, blah, 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 and then every once in a while he calls into chamber. And so what we would basically be doing is one option is to kind of like turn this chamber into like an interface. So then chamber is going to be like some implementation of either wasm or SO or browser, right? But this kind of like sucks a lot of time. I try to avoid interfaces when I can. I don't know if I just find that over time, like it's you always end up with custom behavior, and it sucks. Like it kind of sucks when you like, because now all of a sudden if you want to do something special here, it like affects the API to here and here. It becomes like hard to change stuff. If you want to change stuff in one of the things, you have to like make sure that the API is compatible with all three. It's just kind of like annoying, right? And so I was considering the other option of making like a JavaScript sim, which basically calls into like balls simulation module that does like this stuff as well as like collision and stuff. And then he also calls into like chamber. I was considering doing it this way, but just looking at like the way this is structured and the fact that like this has to happen before this, and then like history is involved in here too. I kind of just have a gut feeling here that an interface will make more sense, especially because of the fact that this chamber mod is already an interface, right? We are already saying that chambers have to implement these sets of APIs. And so if we're just saying that we are wrapping this set of APIs in different contexts that they'll be loaded from, the interface behavior shouldn't end up being that bad. That's kind of like my gut feeling right now. And so that's why I'm kind of like opting to do it this way, even though I would normally not want to. So we'll try it. Sometimes I do this and then I find out that it really is as bad as I thought it was going to be, and then I take it out. But We're gonna keep this for now. So I think what I want to do here is I want to move the mutex for this thing out. Or maybe for now, probably the fastest thing to do is can we do something like basically just make the mutex void if we're not in if we're in wasm. That seems possible. Let's try that. Because I think what I want to do is I just want this one module compiled to WebAssembly, and then we can kind of like see what it takes to make it work a little bit cleaner. Because what will probably happen is we will wrap this module in like a C API because WASM needs a C API to interact with the world. So let's just kind of see where that goes. Let's see where that goes. So we can do something like function mutex type, and this is going to take in some t, and he's going to return another type. Take in a type, spit out a type, and in the normal case, he's going to spit out std thread mutex. And so if we just do this for now, and we just replace this with mutex type, I guess this is going to be a function like this. I guess it doesn't even need to be a function. This can just be a constant. But I think a function makes this easier, I think. We'll see. So if I build this, this should still work. Fuck. I'm in the wrong window. We need to get out of here. Quit this, go over here, close this, say build. There we go. Let's see. Okay, so that still builds, which is really good. Good for us. So now what we can do is we can just put some custom logic in here, and we can say if std or built-in, if built-in it wasm target is wasm. Yeah. We can return void. Otherwise, we return mutex. And then we can just maybe we'll actually return dummy mutex, because that way we actually can just continue to like lock and unlock the mutex in all of the contexts that we do before here. And we just can like say that it will just do nothing. So const dummy mutex is equal to some struct. And this is just going to have a lock and an unlock API. Like this. And I guess this is going to take in a dummy mutex pointer. I guess that's how this works. Yeah. So if we do mutex type here, so that compiles, but we're not running the iswasm path. Let's just kind of do this for a second, just to see if the dummy mutex API is like working at all. So it looks like that compiles as well, which is really good. That means that this will work. Okay, so what is the next thing to do here? The next thing to do here is try to wrap this simulation in some sort of C API that we can use in a WASM module on the client. So we're gonna look at like simulation C API Zig. And this is gonna say, I'm gonna import. Is there a way to build all targets? I think what I'm going to end up writing a WASM compilation of this into the build script. So I don't know if like that's really what you mean. But like our build is defined by this build Zig, and you can do whatever you want here. You can cross compile for whatever the fuck you want. You can do whatever. So yes, I think. And let's just see. So let's start with this like init function. So this init requires an allocator. And so we are going to be using the WASM allocator. He requires a seed and a chamber module that is a WASM chamber. So this is also going to have to change. I guess before we make the C API, what makes sense is to replace this WASM chamber with a generic chamber interface. That's what we want to do. Yeah, so we want to go to. Let's look at who calls this and see how what the storage looks like. How is this going to make sense? So this is probably called by our application. And here, when we create a simulation, I think we call like something like append simulation somewhere, append chamber. Cool. So he creates a chamber, he feeds that into the simulation, and then he stores the chamber. So that's really good. So what we can just do is we can just call here like chamber.interface, right? And get an interface out of it and feed that in here. And then everything should be fine. As long as he has a static memory location, which he will not. But the wasm loader inside kind of points to static memory, so we can maybe get a little clever here. We'll see. No, this is tricky. This is tricky. This needs to return a pointer, unfortunately, but we'll get there. So, yeah. So we're gonna do something like, how do we want to do this? Self alloc create wasm chamber. So we'll say const chamber is equal to this. Then we're gonna do chamber dereference is equal to this thing, and then we're gonna say if we fail, we're gonna deint this thing, and we're also going to free the pointer, which is destroy in this context. It's a single element. Just free for multiple, destroy for single. Okay, now our chamber mods are going to have pointers instead of raw, like the normal thing, and then that means that we are going to have to, when we deinit these things, we're going to have to go over every single chamber mod and call deinit on him, as well as alloc destroy chamber. I think that's right. And then everything else probably just works. Okay. Yeah, I think that's fine. We'll see. So now he doesn't, there's no deinit in pointer to chamber wasm chamber. That's surprising. Maybe this can't be by pointer anymore. That kind of probably fixes it. Okay, wasm chamber found that, so this is at 124. This needs to just be dereferenced for now. We'll fix this in a second, but for now we'll just dereference it. Because we want something compiling that we can work with. And let's just run it to make sure that we don't do anything like really fucking stupid. As my browser, did I close the browser that was relevant here again? I did. Why do I, oh, no, this one. Here we go, refresh. All right, everything's chilling. Okay, so now we did that because we wanted to be able to take in some sort of interface here, which means that we're gonna make like maybe source chamber.zig. And we're basically gonna look at the wasm chamber API here. And try to like start just wrapping it. So we have, okay. So we're gonna have this that is gonna take in self. So we have, what are we calling this? Chamber is equal to this. This is gonna take in a chamber, and we're gonna call this init instead. It is a little confusing. We will call it init chamber. I like that name a little better. And he is going to have some form of vtable, right? That's how you do runtime interfaces. We're going to have data is going to be some sort of any opaque pointer, i.e. a void pointer for you C folks. And we're going to have vtable, which is going to be a chamber vtable. Now we have to make that thing. So we're going to have pub const chamber vtable is equal to something. We don't know what's going to be yet. We don't know what's going to be, but we'll figure it out as we go. Okay. So now what? Our init chamber is just going to call into self vtable init chamber with self data and max balls. Yeah. Yeah, that makes sense. That makes sense. I guess maybe init is like a bad example. Maybe we kind of want the chamber to be initialized externally. Who calls init chamber here? He does call here. Okay, we'll leave it like this for now, but we'll kind of flag this as something that might make sense to be done in an implementation specific way, and maybe just the like long running aspects of this thing are going to be interfaced, but we'll leave this one in for now. Which means that we need some sort of function that we're going to be calling in here. So here we're going to have init chamber is going to be some sort of function pointer that takes in an any opaque as well as a usize. Why is this not okay? Const function? What am I missing here? Oh, this has to say struct here. Chillin'. And he also needs a return type. So the return type is going to be void. Like this. And this has to say any error so that it knows how to like coerce this thing. Okay. Okay. So now let's kind of like make a function on the wasm chamber that creates this interface. So I guess we just kind of call this chamber. Because like in the same way that you have like general purpose allocator dot allocator, this should be wasm chamber dot chamber. I think that makes sense. So we'll kind of put this like here maybe. Pub function chamber. He's going to return a chamber. And he's going to take self by reference. And we are going to start making our vtable. So const vtable is equal to chamber vtable. And we need this to be a global actually. So we're going to say struct globals. Const globals equals struct. In here we're going to have var vtable is going to be a chamber vtable. Ice is going to be a chamber dot chamber vtable, which means we have to import chamber here. Okay. So now we can just say init chamber is equal to how do we want to do this? So we have to like make a wrapper function. What do they do in like the general purpose allocator? Like, what do they do? Do they have like helper functions to like make this less shit? General purpose allocator. So this comes from here. What do they do for like function allocator? They take a they have any opaque as an argument here, and then they just self-cast. Sure. That makes sense, I guess. So here, S chamber vtable. That's a good point. I agree with that. So we can go in the chamber zig, and this, you're right, this should just say vtable like this. That does feel better. Okay. So that kind of means that this is going to say, I'm going to take an any opaque here. O-P-A-Q-U-E. And then this can just say init chamber like this. And then here we will return data equals self and vtable is equal to vtable. Global vtable. Yeah. Yeah, that feels right. And then here we just need to say that self opaque, or let's kind of use the naming scheme that they use here, which is context. They say self is equal to self equals pointer cast align cast ctx. I like that. I like that naming scheme. That feels good. Yeah. Okay, and then we're just gonna give this treatment to all of them. So all of the APIs that we need from simulation. So for simulation, we are going to change this wasm chamber to be, he doesn't know wasm chamber exists. He's only going to take in chamber. This is going to be import chamber zig. And I'm doing this now because we'll just be able to like follow compile errors if we do it this way. So he's going to take in a chamber. And we don't need to do this chamber mod constant. This could be chamber mod like this. And there we go. We have our first function might work. There's probably all sorts of reasons that this is fucking broken, so let's just kind of start working through these. App zig 175. Instead of this passing in chamber dot start, he should be passing chamber dot chamber, which is kind of funny. This is now going to take in a chamber, and now we need to also say that we have chamber here as well. Yes, simple, 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 simple. What else is fucking broken? Init chamber expected this, found that. So in simulation, so in our chamber API, I guess we should allow this. This should be maybe by non-pointer. What do they do on the allocator API in standard library? We take ourselves. No, not wrong. What the fuck? Pub function. Okay, they take themselves by value because by value turns into by pointer. It's up to the interpretation of the compiler if he thinks that it should be by value or by pointer. He gets to choose. And I can see the argument here where by value could make more sense because this is just two 64-bit ints or something. This should be a pointer to a vtable, huh? That makes more sense because then this just turns into two like 16 bytes. Yeah. Where here they might inline the whole table and we don't want them to, and I don't know if the Zig compiler is smart enough to like do things to structs that way. Okay, so global vtable needs to be now by reference in here. So this could be like this. Boom. Error union is ignored at 11. We can just return this. No function load. Okay, so now we can just start working through what things need to be implemented. So here we'll just start by stubbing them out to kind of fix compile errors, and then we can start implementing them as we go. So this expects a chamber save to be injected. So this is a save is a const u8, I think. Little buffer. No field name save, so we can just do the same thing, where save now takes in an allocator. And I assume returns a slice. So const stud is equal to import stud. And then const allocator is equal to stud mem allocator. Bing, bang, boom. Which means that here we need to stub out something. We'll just write unreachable. And here we need to say ignore the alloc. Function parameter shadows declaration of save. Oh, fine. Call it data here then. Fine, if you're gonna be like that. Okay, what's next? No field or function named step. So step takes in the balls pointer as well as the delta. So it's taking in balls as a slice of ball, which means that we need to import physics. And from physics, extract the ball. So here we take in the balls, and then it was the delta as an F32, I think. Could be wrong there. And then we stub this out, and probably there's no return. Probably. We could look, or we could just blindly type. Nothing, okay. Oh, that's a whole interface. That's really not that much. Sick. So now we just have to turn these into like vtables. So we're just gonna maybe slap this here. We're gonna do delete all of this, delete all of this, delete all of this. Come up like this. This turns into something that's like We delete the word, we go to the bracket, we put a colon, and then we type const function. And then we go to the end, and we go back by one and put a comma. Oh, I love it when it just works, man. And then this is probably complaining about this thing is being any error. Boom, boom. And do they let us put the names in here? That's kind of nice. That's kind of nice. Okay. I don't know if I'm missing a joke. Bro, you trying to fight in Ukraine? I don't know if this is something that I should be like, shut the fuck up, don't talk about that here, or if it's like there's some joke that I missed. So I'll give you a chance to defend yourself. So this is gonna call vtable load with data. This is gonna call vtable save with alloc. And this is gonna call vtable step with balls and delta. Chillin'. That's super easy. Super easy. Which means our wasm chamber now just kind of needs to Mick the Merciful. he gives him the chance. That's pretty funny. Okay. So this guys are like this. This is gonna just say I'm gonna equal load. This is gonna say I'm gonna equal save. Here it's gonna say I'm gonna equal step. Okay. Okay. Then we just need to fix our load, save, and step function. So these actually don't have to be public anymore, which is kind of interesting because they go through the interface now. So this goes load. This is now an any opaque. Any opaque, which I can't fucking spell ever, and then we're gonna rename it to CTX. So we can do this. What was it? It was load, save, and step. So this is like this. Context is any opaque and step. This is gonna get any opaque. Oh my gosh, I can never spell it. And this is like rename CTX. All right. Okay. So that builds. I really feel like I'm missing something. Like there's other functions in here that are exported. Like for example, dinit chamber. But I guess these are called from a context of like, oh, just nobody calls that. That's kind of funny. So we just have our dinit function, nobody calls it. So we should actually just like, just kind of delete that. That's dead code. We don't need dead code around here. So let's just kind of like get rid of all of that. Okay, that explains a lot. I was like, I feel like there's more, but there isn't more because we just don't call that shit. Because like the other exported parts of the WebAssembly API are kind of hidden by this like simpler interface, which is kind of nice, right? Like things like needing to know where the balls are stored in WASM memory, that's kind of like handled within the function of step. Right here, he calls balls memory as part of him, but like his external API doesn't need that. And so the external API is actually pretty simple. So I guess if we run this, like really everything should just work. So that's good. We've kind of like got our simulation Zig file kind of to the point where I would expect it to run. What is in resources? It's not using that. Okay, delete that. Built-in is being used. Chamber is being used. Physics is certainly being used. But now like the only parts that were requiring like x86 specific code, the chamber and the mutex are both kind of gone. I guess the mutex wasn't x86 specific, but it wouldn't work in WASM, I assume. I actually haven't checked that, but I assume. So I think we are kind of in the point now where we can maybe make our simulation C API and we can just start wrapping it. So he is going to take some chamber, but this is kind of weird. I don't know how to handle this one. So maybe we skip this for a second. We do init last. And instead, let's figure out a function like step. So step is going to take in. Let me think about this. We can give this the same treatment that we gave to our other WASM modules, where we are just going to have a simulation in static namespace. Yeah. That feels right. Okay. And then he is going to have to be initialized in some way, shape, or form. We are going to have to call this somehow. And so our allocator here, we can maybe make like a public. I've changed mine now. We're going to look at function init. And here we can pass in a seed of a usize. Was that what it is? Yeah. And we can call, we also need the chamber mod. Now this is where it gets kind of interesting in that the chamber mod will be defined as like an import block, I guess, to the module, right? Like if we are going to say that we have like chamber API calls JavaScript bound function, we almost can just make the chamber module also static. Hear me out. Because our like what we're gonna have is we're gonna have some sort of like imported function that's gonna be called step, and he's gonna like implement something that's gonna come from JavaScript land. Yeah. Wait. This makes sense. So then we can go back. Let's go to the wasm chamber and copy our vtable instantiation. We can just do this. We can say we have a vtable, and the vtable has extern functions load, save, and step. And we implement them in terms of this thing. Yeah, I feel like there's something here. So for now, we just fuck this shit up. We could even do this. We'll come back in a second. But that means that here, when we initialize our simulation, we can say, what editor is this? This is NeoVim. You have Vim in your name, so I don't know if you're just asking because you're fucking around. Like you're like, what color is that? And it's like blue, and you're like, oh, I've never heard of blue before. Like you're trying to like shove like blue into people's heads, or if it's just a coincidence that you have Vim in your name and you don't know what this is. Both are kind of funny. Okay. So here we go, simulation init. And now we have like something, we can use stood. Okay, we need const stood. No, I was genuine. Didn't even realize I'd been my name, Raffle. Okay, that's pretty good. Sorry, not to make you feel bad if I wasn't trying to be like, fuck you for asking. Like, I was just pointing out that it's kind of funny. Okay, so here we need to create a chamber out of this vtable. So we can actually do the same thing here. We say like const chamber is equal to a, this can be lowercase chamber is equal to chamber. And in here, we need chamber imported. Yeah. Okay, and then here we can just say data is undefined. And vtable is equal to a vtable. And so now we have like a global chamber mod that we can pass in here, and this should compile. Now we have a problem that this should be a pub export function. Use of undeclared identifier chamber, because I spelled chamber wrong. You misspelled chamber. You missed as Chabner, which sounds pretty cool, unfortunately. Yeah, Chabmer. It's like Chadner. Like a super cool chamber. Because he's a chat. I should shut the fuck up. I should just. Why the fuck do I. Okay, sorry. We'll start this as undefined as well. And so if we try to compile this simulation C API, we should get something interesting, I think. So we go to our build script. And we have build chamber, which is going to be kind of close. So I'm going to copy paste this and call this build client side sim. Okay, so he's going to come from source simulation C API. Hello, why can't I fucking autocomplete? There we go. And this has nothing here, and we don't have to allocate anything. We can just hard code this here. So we'll call this simulation C, simulation, I guess we'll just call it simulation, huh? And here it will be a wasm thing. We don't need to anonymous import physics, I don't think. But all of this stuff will stay the same, and we'll call this, instead of chamber, we'll call this sim. This path now doesn't look like this. It looks like goes in here. Physics simulation C API, nice. And then this stuff just gets sim. How do you feel over the dev experience of Rust versus Zig with wasm as a target? I've been having fun with Rust, but considering taking Zig on a ride for the game I've been building. Okay, so I think the Rust wasm dev experience specifically is very tailored towards you not even thinking about WebAssembly. Now, with the way that we behave on this stream, I think that I do not like wasm bindgen anymore. But that is like not because it's not a good tool. It is because like the mindset that we embrace on this stream is very like, don't abstract things for me, or if you do abstract things for me, I need to understand the abstraction myself, right? And so when I've built wasm applications in Rust before, and I didn't really understand the memory model. I didn't. So for things like I wrote this app at some point where I was playing with the idea of rendering a map of my city in WebAssembly, which is actually something that I'm considering revisiting. And like, so the idea of I had like 40 megs of like data that I was shipping over from my server to JavaScript, and I was like, how the fuck do I get this into WebAssembly land? And I didn't like understand like kind of like the trade-offs that you would have to make to do that. Right, because like with Rust's WebAssembly API, you just write a function and then you take in stuff. And so you're like, well, what if where does the stuff come from and where does it go? And so like now if I were to do that with the knowledge I know now, I would like basically like fetch directly into WebAssembly module, like fetch with the JSON over the network directly into WebAssembly, then parse the JSON in the WebAssembly module from the memory buffer that like was fed in externally. But like because I didn't know that, I didn't really know how to do that correctly. And so like there's something about like even if the abstraction is zero cost, like you have to understand what that abstraction is in order to like use it well. And so like I feel like there's probably like the web sys bindings are very nice because they let you just like you can just use Rust and Glow and use WebGL from your WebAssembly module, and that's like very powerful and you get up and running very quickly. But like now that I know how it all works, it's like, do I want that? I don't know. Maybe I would rather feed in like the OpenGL. Maybe I would rather craft the OpenGL calls in JavaScript and feed in just this like one function that does the OpenGL stuff that I want. Because in reality, it doesn't make sense for us to go over that like WASM JavaScript boundary like 10 times when you can do it once. Is like my current mental model, right? So, that being said, the development experience is very different, right? Because now like you don't have WebSys in Zig. And so like if you're just trying to interact with the canvas from your WebAssembly code, you'll be like slamming your face into the wall because like that's not something that Zig provides you. Maybe somebody's given that module, like maybe somebody's done that work for you already. I haven't looked, right? So I can't really say that. And if you're asking about like the general development experience of like Rust versus Zig, they're also like quite different. And like right now I'm favoring Zig because I'm enjoying the freedom that it gives me, but that doesn't mean that I like dislike the Rust development experience. So it's just apples and oranges. Continuing with Rust for now. Yeah, I think that makes a lot of sense. Oh, continuing with Rust, but force yourself to drop web system bindgen to force myself to learn more. That's kind of fun. I like that. I like that approach. Doing it in bite-sized pieces sounds kind of fun. And I will say that like there's nothing wrong with using bindgen and WebSys if you're just trying to like make a WebAssembly thing, right? Like the reasons that you would drop it is just like for the learning, and if that's what you're motivated by, then like fuck it, go ahead, right? But I don't want to like make it seem like I'm like, no, you're wrong for doing like what everybody else does. Like I don't want to come across that way. Okay, so this is takes in a build, and what does this thing take in? An optimize mode. And now if we build this, we should see a WebAssembly module pop out somewhere. Maybe? He's mad because I didn't write try somewhere at simulation C API. So I guess we can just write a catch here and panic. Because I think that this will just turn into something, I guess unreachable probably makes more sense. This will just turn into a trap in WebAssembly land, which we can live with. And so now if we look in zig out bin, we should have simulation wasm, which is very cool, very cool. And if we wasm to what simulation.wasm, fuck. Okay, this is impossible to parse unless we do zig build optimize release small. Probably makes the most sense. That'll give us the least amount of what to look at. WebAssembly text. So let's look at, wow, that's a fast build. So if we go now, we look at wasm to what simulation. We should see a function called init, good, which is function 0. And function 0 has, it takes in one parameter, which is the seed, and he like does some stuff. So we have like reasonable proof, I think, with like the amount of stuff in here that we are in fact compiling the simulation, right? We can see things like function 0, like what is he doing? He's like looping over this stuff and branching and calling other functions and clear zeroing. So like surely that's like going in here and like calling like make balls, which would be this loop. So we could look for maybe a like a loop of 5, and if that's in there, then we have like pretty good indication that that's doing the right thing. So this loop branch if 0, and he's using label at 1. How do I? So here he's comparing something in 41, so that's probably not the one. Maybe we can look a little farther down the stack. BR if 4 and 3, 2 and 4. I got too hopeful. I don't think we're not gonna find it, but I think that I'm like still somewhat confident. We'll just go a little farther and see if we can load the thing and get some confirmation. In fact, in here, it's not straightforward yet. It's not straightforward yet. Let's just keep going and see what happens. I don't like the fact that I have to write data here is undefined. It kind of feels like there might just not be a context pointer here, and all of these guys should just accept that. Right? Oops, I put the question mark on the wrong side. Right? Which means that this isn't going to build anymore, but that's okay. We can just go fix it. So this is going to be in like wasm chamber. We have like init chamber. All of these functions just have to say this. Load, we can just look for ctx colon and do this. Boom, 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 boom. And it's okay that we don't actually null check these things because in debug mode, we will crash because the pointer cast won't work. And in release mode, we should be pretty guaranteed that we're using the fucking right interface. Like if we're feeding data into our interface that isn't the data that we want, like fuck us, you know? Like fuck whoever did that to us. This data now is correct. Okay, and so now we can just write null here, which is great. Now our vtable, we can start stubbing it out. So let's at least give, well, I guess we do this. So init chamber, what is the API of this thing? This is self, and this is max balls. Cool. So let's think about this. He, I guess, will be called with max balls. I guess that makes sense. We can just leave it up to JavaScript to choose how many balls he wants in his simulation. Does that make sense? No, because this is hard-coded here. Oh, I'm fucking stupid. I'm stupid. This just has, that's not how this works. So we need a function here, an extern function init chamber. And he needs to have, he's just going to take max balls, I guess. Maybe. We'll see. Maybe he needs a context pointer, but I don't imagine that he does, but we'll see. We'll see what it looks like on the JavaScript side. And he is going to, instead of returning any error, I guess he'll return a bool, because this has to be something that is like expressible from C. And we want actually extern function like this. Right? Extern. Surely we've written extern somewhere else. Am I fucking stupid? Has anyone else noted that they find it weird that he calling struct functions he instead of it? Well, I like to like anthropomorphize my code so that I can get in its head. You know, you can like I can like imagine the characters in the code base better if they are like people, and because I live in a world where guys are the default gender, I say he every time, but really I could say she. It wouldn't really make a difference, right? I just like want to like get it in my head that like it's just easy like he's over there, he's picking up the bites and he's slurping them up and he's putting them over here. It just like feels like I can like visualize better, like in the same way that people use like those memory tricks where they like imagine stuff on the walls of a house because like your stupid fucking monkey brain is like evolved to like think about things that you see in the world, and so I just like turn the code into things that I've seen in the world to like rationalize about them better. It's like fucking stupid, but I think it's like legitimately helpful for me to think of it that way, which is like fucking stupid. You could create triangle dramas in your code with H's and G's. Yeah, like little love triangles. Okay, what was I trying to do? I was trying to look at a zig export C function because oh wait, this should be in platforms. We must have done this. Oh, this is export. I want intern. So we had like log wasm, extern function. So it should just be this. Extern function, log wasm. So what's the problem? In platforms, we have log wasm. This is just extern function. Oh, because we have to put semicolons because we're not implementing this function. We are just saying that it exists in the world. That makes so much sense. Okay, so now we can say that we need an implementation that basically wraps this API into calling this external C API function. So we'll call this external init chamber C. Can I like wrap these in a struct? Can I say like struct? Can I do like const C is equal to this? Is this legal? Because then I can do something like a function init chamber that takes in any opaque that we don't give a fuck about, and a max balls, which takes in which is a usize. That this will return an any error void. Then we can just call the C init chamber with max balls, and if this returns false, then we return an error. Is that stupid? And then here I just write init chamber. Like, that looks like it compiles, which is pretty cool. So now we can actually try loading this thing in like a dummy web page and see if we can call init chamber and like see if we can, when we should load this WebAssembly module, call init, and we should see it call back into us. Is that even what we fucking want? Yes, because he's doing all sorts of other init here as well. Right. Okay, this makes sense. It felt stupid for a second, but it makes sense, and I promise it makes sense. And if you don't believe me, just believe. I guess we kind of finished this at some point, and we're like definitely on glue code. So this is at like some time before 5330. Okay. So. We need to make a test HTML. Who has a head and a body. Which part of the code is the foot? We can add a foot here. Because he already has head and body. He's gonna have a script is equal to test.js. This goes like this. Source equals like this, right? And here we'll write hello world. We will edit test.js as well, and maybe write a console log hello world. And then we will spawn a Python HTTP server because you can't instantiate WebAssembly without a real server for some fucking reason. I mean, we actually went over this. Somebody showed me the answer, and it had to do with the fact that you're worried about like clicking on a file, like just an HTML file that like you downloaded and that like doing something fucking stupid. I think that might have been it. I can't remember. What the fuck is this doing for so long? Okay, Python -m HTTP server. We go localhost 8000. Okay, we'll type test HTML, I guess, if you want us to. We have a hello world, and we have a hello world. Okay, so let's just kind of hide that shit, and we're gonna look at index. Even if you click it and it does something stupid, it should be sandbox. That's a good point. I think it's one of those things where I heard it and I was like, that makes sense, and it didn't like sink into my brain, so I can't repeat it because I don't actually remember, which is kind of funny. Okay, so we are going to have to load some. We know how to load some WebAssemblies here. Instantiate streaming. So let's do await init. No, async function async function init. I know how to fucking write code. Like, what the fuck are you guys talking about? Shut the fuck up. We need to give it an import object. So import object has env and a function that we want to implement. So that's gonna go here. And oh my god, set expand tab shift width equal 4 tab stock equal 4. Okay, fuck off. GG equals G. Okay. So our environment, he doesn't need a log file, he needs something else. What was this thing called? It was called like simulation C API? Yeah. So he wants max balls. Init chamber max balls. So this thing is gonna have init chamber, and it's gonna go called init chamber, and we're gonna have some function init chamber that takes in max balls, and we can console log init called with max balls. Okay, and then window onload equals init, and then here we say init. We say console log initing now man, thank you, smiley face. It's crazy, like this is like the internal monologue in my brain is like, this is what I'm thinking. What a fucking useless like word soup that's coming out of my brain. It's just so fucking stupid. Okay, so we're gonna fetch I guess it's gonna be zig out bin. What is it? Zig out simulation wasm. Simulation wasm. Sick. And this gives it the import obj, and we should just be called obj instance exports init. And if all of this works, we should see this console log with max balls 5. That's what I'm hoping to see here. Oh, hell yeah, baby. Hell fucking yeah. That's so sick. Sidetrack, this new Zig package index is coming along, which includes GitHub repo, so the Zig package topic, as far as I know. Oh, interesting. So this is like the Zig equivalent of cargo or crates.io. Shouldn't max balls be 2? No, I think max balls should be 5 because we have max balls is defined in simulation Zig. He has like a number of balls hard coded here. Num balls is 5. I don't know where you're getting the 2 from, but it's hard coded here is 5. So that's the correct number. That is the correct number. Wait, wasm on the server? Are you running bytecode directly? Okay, so there's so much going on here. There's like so much. Okay, saying let's not get ahead of it. Let's not float around boats too hard. But there is like a few things happening here. So for those of you who haven't been am I in the wrong folder? That's why. For those of you who have not been in and out of this stream in the past couple weeks, we are working on this like. Fuck off because my adders in use. God damn it. Okay. We're working on this collaborative Rube Goldberg machine. So the idea here is that this is like a physics simulation that's running on the server, right? So I refresh this and I get the exact same physics state, right? The idea here is that we're going to create this Rube Goldberg machine where it's going to have like tons and tons of chambers. Each chamber is defined by a WebAssembly module, right? So these platforms right now, these are completely defined in WebAssembly. And what is happening is this like physics simulation is calling into the WebAssembly module. The WebAssembly module has a list of like the balls. And when he sees a collision between a platform and a ball, he applies the physics response that he needs for the balls to move the way they move. The server is then doing like other like ball on ball interactions. He's applying gravity, he's applying velocity, stuff like that. But like the chamber is defining the bounce of the ball. So that's where like wasm on the server is coming from. This same wasm module is also running on the client and like rendering this stuff. And now we're trying to look at like, well, for testing, it kind of makes sense for someone to be able to just like shove a wasm module at the screen and like see how it runs. And so now we're trying to say, well, this physics simulation that right now is running on the server, let's also make it run on the client. Right, so that's why we have wasm on the server, Zig on the client. It's like the clickbaity Twitch title, but it's true. It is true that we have both of those things. If wasm plus WASI existed in 2008, we wouldn't have needed to create Docker. That's so important as web selling on the server is the future of computing, something like that. Docker founder. I do like that idea of WASI. I don't WASI instead of Docker. I don't know how much I like the. Well, I don't know how much I like it because like there's got to be some sort of performance hit of running all of your shit through this like wasm virtual machine. But I do like the wasm virtual machine. So I don't know if this post zero interest world will work towards removing layers and indirections not anymore. That's kind of what I think as well. Like the extra layer of indirection feels wrong to me, but so does Docker. They both feel kind of wrong to me. What is WASI exactly? WASI is this. It's like POSIX for WebAssembly. So it's like a list of like APIs that you can expect to exist, and your like WASM runtime, i.e., like your browser, but not your browser, like whoever's running the WebAssembly, he will implement the POSIX API for you, kind of, something like that. It lets you compile with like standard library and stuff, right? I'm not sure if it's exactly POSIX. I just know it's like an API that like you can implement for libc essentially, and have like file I/O and like network I/O and stuff like that. Okay, so in our test JavaScript, we are going to have some chamber loaded, right? We're probably going to want to do something very similar that we do in index JavaScript, where we load some chamber, and what I guess we kind of want this whole chamber class in here as well, that like creates a canvas for us. I am going to copy paste this like a fucking noob, right? And you guys are going to shut the fuck up about it. I don't want to hear it because we are just trying to get up and running with some sort of test right now. We have to do something. I saw nothing. Yeah, perfect. Thank you. Bury your heads in the sand. Thank you. Thank you. Thank you. And his render function, he requires get chamber pixels, and that's kind of it. So we're gonna copy paste get chamber pixels as well. So that's gonna go where the fuck we were over here, get chamber pixels. And so I guess we're going to want to go the same way we load here. We're gonna want to load a chamber. A chamber. So this is, I guess we're gonna put the chamber in like the global namespace for now. And what do you do, right? Var chamber, let. It's in global, so I guess var is fine. And then here, when we call this, we're gonna fetch from zig out bin platforms wasm, right? Let's just have like something to work with. This is gonna use a different import object, so we're gonna call this simulation import, and we'll call this chamber import. And this is just gonna have like log wasm, and we're gonna just stub this shit out. We don't actually need it. We just need the function to exist for this API to work out. So we're gonna call this chamber import. Is this open source? If it is, can I get a link? It's, yeah, I usually write this over here, so I should write Spheraphoria ball machine on GitHub. I will link it. And if you want to see previous development, that's all on YouTube as well. There should be a link to both the GitHub and the YouTube in the Twitch description. So if you want to check out like everything else, there's a playlist for it. I might as well plug it a little bit, you know? So we have, fuck, that's not what I want. Shut the fuck up.
Hi there, my name is...
Shut up, fuck. Yeah, here's the history of this thing. So it's there if you want to check it out. But of course, no pressure. I can't choose what you do. You're not me. Okay, so this guy needs his chamber import. And our chamber import needs a function log wasm that takes in A and B and does nothing for now. That's fine. Okay, so does the thing like run if we go back to as our Python MHTTP server? Let's refresh this guy and just see how fucked it is. So I is not defined somewhere. 117. Right. I just wrote 0. Address already in use, right? That makes sense because that's not what we're doing right now. Can't access lexical declaration ob before initialization, so that makes a lot of sense. It should be called chamber. Refresh. We got through to the end of init. Right, so our chamber is calling into simulation state to get the simulation state, but that's not how this is going to work anymore, right? Because this is going to actually have to pull out the simulation state from our client-side WebAssembly module. So I guess we will have to figure that out eventually. We will have to figure it out eventually, but not quite right now. So for now, I'm just going to not call render. But we should now have a chamber to interact with. So now our init chamber function, where the fuck that was, should be able to call like chamber exports init with like whatever parameters that we've passed in, right? So it's like chamber instance exports init. And what is it called? Platform zig. So we call init with max balls and max chamber pixels. So this is going to be max balls is given to us by max balls. And we're not rendering with this one. I guess we kind of are, huh? So we actually kind of want 600 by 450 times, yeah, that's fine. This is kind of interesting. I don't think that we've ever instantiated one that both does physics and renders before. So this is we're gonna see if we fucked up anything major here. Okay. So that's the first thing. And then we can just start stubbing out the other function we need. We need save, which was, fuck my brain, chamber zig. So save takes in nothing really. Oh, he has like some memory associated with them. Let's do step first. I feel like that's gonna make more sense. So we can step this thing, and he's gonna take in some balls and a delta. And that's gonna somehow map to the chamber version of platform zig. He has a step function in here who takes in a number of balls and a delta. So what we are gonna have to do here. Oh, this is interesting. Okay. I need to draw this out to like formalize my mental model, but also because you guys don't know what the fuck I'm thinking in my head. So we kind of hit two birds with one stone here. So we have our simulation somewhere, right? And we also have chamber. Now, the model for both of these is that they own some memory, right? And what we're trying to do here is we're actually trying to say, like, I have a simulation that has like some balls in memory here, and I have a chamber that has some balls in memory over here. Or no, that has a step function that will access the memory here. And so what we need to do is when we call our step function in the simulation side, we need to find our balls in memory here, ask the JavaScript to copy those balls out from here and stick them over here, and then call the step function. And then when the step function is done, take these balls and just copy them fucking back. I think that that's what we're supposed to be doing here. Which makes sense because that's why this balls API is like this. So, okay. So I'm gonna copy paste this here just so that I don't have to have this split open. And then here we can go to the test JavaScript. His step function is going to take in the memory location of the balls. So balls pointer. He, I guess, should also take in the number of balls. That makes sense to me. As well as the delta. We are going to copy balls pointer from 0 to num balls from simulation memory into chamber memory. Okay. That makes sense to me. So we're going to say like chamber instance exports balls memory. And this is going to be the chamber dest is this, right? Uh, we are going to say let fuck sim source is equal to, this is already balls pointer. Okay, so we have like fuck. My poor little stupid fucking brain. He's in so much pain, guys. He's in so much pain. Okay. I'm thinking. So we need to store the simulation somewhere so that we can access its memory. So we'll just call this simulation like this, and then we'll have var simulation is equal to null. That way, in this function callback, we can get the simulation memory. So we'll say simulation. Can we like tag what this thing is? Like, why doesn't it know? I wish it knew. We usually like type web assembly. No, I don't know. What does this thing return? WebAssembly instantiate streaming returns a. No, this is not useful. This is not useful. Okay, I'm just gonna give up. It's fine. We can figure it out. So we'll just type here and then copy paste it out. Simulation instance exports memory. Exports. I think it's just memory. I think it doesn't even autocomplete, but sim memory is equal to this. And I guess we can actually reference index.js, so we must do this somewhere. So we look at chamber instance exports memory buffer, and we turn that into a uint clamped array. I guess we probably can do this here, where we get a uint8 array, right? So we can say that this is the, we can call this the sim balls is this from balls pointer to balls pointer plus num balls times size of ball. So maybe instead of calling this num balls, we'll just call this like byte len. I think that makes more sense. So this is just going to be this plus byte len. Then we're going to have the chamber balls is going to be very similar. He's going to be this, the same fucking thing. But he is going to be, this should be sim, oops. Chamber memory buffer, and he's going to be from this. So let chamber dest, I actually had that variable already. And this is going to be chamber dest plus byte len. That feels right to me. Let's double check the uint8 array. So he is byte offset and length. So this plus here is just fucking stupid. This should be length. Yeah. And then we should be able to like copy from one to the other. Is there like a uint8 array copy from other uint8 array? That sounds right. Set. Okay. So then we can just do chamber balls set sim balls. And then we should be able to just call chamber. We should be able to call then chamber instance exports step. Yeah. That sounds right. Which takes in the number of balls and the delta. So here we'll take in the num balls as well. And then we just copy the fucking shit back. That sounds right to me. That sounds fucking good. Okay. And maybe even here we can console log chamber balls and log it here as well, just to make sure that like we won't really be able to tell if it makes sense. What will make sense is we're gonna have to maybe maybe it makes sense for us to pass in the log wasm function to the simulation as well, and at least get like some sort of logging ability, because that will just make our lives easier. So let's do that. Let's do that. So we can go back into our, what was it called? Simulation C API. Here we can say that we expect some sort of external function log wasm who takes in a pointer tu8 as well as a len. I'm so lost right now. My head is full of monkeys playing cymbals. Cymbals. That's pretty funny. Yeah, sorry. It's so hard to like keep in our heads. It's quite difficult. So I'm also lost. Don't worry. His log wasm is going to be log wasm sim because our log wasm needs to know where the memory is that he's pulling the pointers from. So this should just be very similar to this. So we'll set log wasm sim. We'll delete this comment and we'll replace chamber here with simulation. And I think this will work. I think this will work. And so we can take it from our physics, our platforms. See, I think we implemented a print function here. Hell yeah, we did. So this stuff can go into simulation C API. We'll kind of just slap this here. And let's just start by trying to print something here. Print hi, smile. Let's just see if this all kind of comes together. We did get a high smile here. That's very good for us. That's very good for us. So our printing is working. I'm a bit late, but finally made it. What did I miss? Okay. We did a lot. We did a lot. So we took our like simulation stuff, and this is a good recap for everybody else. So that's why I'm okay with saying it for you because I feel like it's been a minute. We took this simulation stuff, and before this used to hold like a WebAssembly instantiation of wasm time. We've kind of made this like a generic API, and that as well as like stubbed out this mutex. And what this allows us to do is this allows us to run our compile our simulation to WebAssembly. So we've compiled our simulation into WebAssembly, and the idea here is that we want to be able to run the entire simulation client side so that we can like preview chambers. Like you can imagine like in like the chamber overview where like users can manage their own chambers as well as like a testing UI. Both of those places you might want to like run a simulation but not necessarily bog down the server with that simulation. So that's kind of what we're looking at right now. And so we've like made this like a generic API, and we've started trying to stub out this API. So now what's happening is we have like the browser is basically coordinating between two WebAssembly modules. The browser is coordinating between the simulation as well as the chamber that the simulation is running on. And so we're kind of like working out that API right now and looking at stuff like this, where we're saying like we have simulation memory and chamber memory, and we have to like copy stuff between them in and out when we call functions. What this like interface that before we would like call chamber step, this actually goes back into JavaScript, then back into the chamber, then back into JavaScript, then back into the simulation. So that's kind of what we're working on right now. So I think we implemented a step function that seemed kind of sane. We just need to let's in here. Let's implement our step function. So we will export a step function. And I think that, what does our simulation internal step look like? Nothing. He doesn't, it's literally nothing. So this has no parameters needed. And he's just gonna call it simulation step. Did you finish the video editor? I got it to the point where I could use it enough to try it. And when I got to that point, I tried using it, and I didn't like the VODs I was producing, or the cut downs of VODs I was producing, so I just stopped working on it because I didn't care anymore. Oh yeah, nice. Somebody's got the rip link there. Perfect. Thank you. Okay, so for after a step, I would like to see that the balls before and after have changed. So we should be able to do something like print simulation balls before and after. And if everything is hooked up right, we should see something. I guess this is a problem because the simulation is also going to run some stuff that isn't dependent on the chamber. But it's okay. We'll at least see that we're doing something right. Okay, let's implement the step function here. So this step function has to go into a C exported function that is called step. And what did we say that the step is going to be? Bunch of copies sound slow. Can you have shared memory between location of the two WASM instances? You can, but I think that the number of copies, like if it's going to be like 10 balls, it doesn't fucking matter. And like it'll be it's easier to do it that way because like when you just compile a WASM module, so you're technically the WASM spec says that you can have one chunk of memory. Either it is fed into you by your loader or you export it. And all of our like like if you just like compile a WASM module with Zig, it assumes that it owns the memory. And so it's just easier right now to think of a memory as exported instead of imported, but you're right that you could share some memory between them, but I just don't want to deal with that. Also, like the allocation scheme between that becomes like a lot more complex, right? Because now you have to make sure that like the memory of the two modules isn't clobbering each other and stuff like that. So there's just like, it's just a pain. You could add there's an extension to the WASM spec that says you can have multiple memories. Then we could feed in one memory that we say is like shared ball space, but like I just don't want to like that's not like technically in spec yet, and so I don't want to think about it. But you're right. You're right. Okay, so this we in our test JavaScript we implemented a shitty step function. This. So we will just say here step is step, and then here we will say that we have some extern function step that takes in these parameters. Okay. So balls pointer is just a like any opaque. Byte len I guess is a U size. Num balls also feels like a U size, and delta is a float. Which means that when we call our step function, now we have, so there's the C implementation as well as our implementation for our internal chamber interface. So this is function step, and we need to follow this API for this one. And then the glue between the two should start to become apparent. But we'll see. We shall see. Okay. So self gets discarded. We don't give a fuck about self because we have no like state associated with us. Balls, we need to maybe say const ball is equal to physics ball, and then we need to const physics is equal to import physics sig. Okay. So here are balls to go into this API. We're going to call C step with the balls pointer is balls pointer. Byte len is balls.len times size of ball. Okay. Then we have number of balls, which is just balls len. And then the delta is going to be delta. Does he return a bool? No, I don't think so. I think he just returns void. Okay. How did I end up here? That's fine. We'll just go back. I don't know. And I think that's it. I think that's it. So then here we can say that step is step. And, oh, that's annoying. That is annoying. So we'll call this a step chamber, I guess. That makes sense. And then this chamber says step chamber, and then we can export a step function, which makes sense. Okay. Problems. So he doesn't like that I'm trying to import POSIX from somewhere, some transitive include. So this must have come from physics. I don't know where though. Named FDT. Where is this coming from? FS file? Can I run with zig build f reference trace? Zig build help trace. I just spelled f reference wrong. F reference trace. Oh, there. Okay. So this is coming from. Oh, from fucking the logger. So we need to do something clever, like stub out the log function. Pub const std. It's something like stud options. Oh, we're gonna have to like log ops stud options. Pub const stud. No, that doesn't seem right. Stud options. Stud options underscore stud options. And what is the type of this thing? An options. Right, and we can just say log function here. Okay, so the stud options is a stud options, and we have a log function is equal to no log. Or we could get crazy here. We could get crazy here. Let's try it. So if we paste this and we say log, we could implement this in terms of our console logger. We can just say print format args. Yeah, let's see. Trap, thanks for the raid. What's up, you guys? What is up? So now this dependency loop detected. Why? Oh, maybe I need to write this like my log or something. It's probably just some bullshit. Then log level here is stud log level, probably. Okay, there, that compiles. Good. So now we should be able to, in like our test.js, step the simulation and just see what happens. So here we should be able to go back over to our refresh here, and something probably breaks. Initting now man thank you is logged. Do we lose the I feel like this ran before. We had like a high in it. So this is in what was the function? The C sim C API. Oh, we just don't print there anymore. Let's try printing here. Hi, smiley face. Let's just make sure that this still runs. We'll write bye here. Do we see? Okay, wait, we see hi. Interestingly, we don't see bye, which is a little concerning. So here, maybe we could say sim init failed. Maybe this has just been broken the whole time. It doesn't look like I'm seeing like a sim init failed, so it just says hi and then never returns. That's a little weird. Can we like stud log error hello? Let's just see if we get like log errors. So we should now because the logger is going back through the console log. Okay, so that's good. We see that hello, and let's just hello 2, hello 3. Like, so he's not getting to hello 3. So this init chamber fails. So we go back to our C API. We have an init chamber function here. And do we just say stud log error init failed here? This must be where it's like falling over. What the fuck? Init chamber. What the fuck is going on? Init chamber all good in the hood. So it's just not going to either of these paths? Like, hello? Oh, is init chamber... Maybe we don't return a bool and that fucks it up? And it traps? That's possible. Can we go back to our test.js? And here we have our init chamber function somewhere. And here we need to return true to say we succeeded. Okay, let's see here. Like console log initing. And here we can say init failed. Oh, wait. Wait, something's happening. Something's happening. We're seeing balls. The balls are... They are getting logged. So it looks like our shit's running. So the bool return did seem to fix that. It's just that it's fucking slow. Can I like... Okay, let's get rid of those prints. And reopen this tab and open this and go refresh. Okay. So I think we're chilling. So now we need to do somehow extract the balls. Probably what makes sense is we extract the balls as JSON so that the JavaScript can process those balls. Yeah, I think that makes sense. We can like make it so that the API of this thing matches the network API from when we get the simulation state from the server. And then everything should just kind of work out, I think. Because then we can actually like visualize it, which will be very, very, very helpful. So in test.js, we call simulation state. And so now we probably just want to create a simulation state API on our simulation C API. So we'll just call pub export function state. And we'll return, I guess we will return, fuck. I want to return like a pointer and a length, but that's not really trivial to do here because you only have like one return value. How do we do this? We could return a pointer that's null terminated, which is gross, but works for me. And this is gonna be like, for now, we'll just say that we have state buff is a global. I know, it's gross, but I think it's the easiest way to do this for now. And we'll just say that this is like, we won't support serializing something that's like greater than 4K. Right? Now we can do something like, okay, how do we do like the normal simulation state serialization? I think it actually comes from this. So we actually might just be like fucking call. No, it's not from here. It's probably in our server zig. Simulation state. This goes to dot simulation state, which goes to response body comes from out buff to own slice. So we stringify the response content, where the response content is this. Okay. So we just want simulation.balls. We don't care about the chamber state because we actually have the chamber state already. So we just want balls. Okay, that makes sense. So this is just going to be an array of 5 balls. So we can actually just create a JSON serializer here. Is there like a std.io fixed buffer stream is probably what I want here. This is going to wrap the state buff, right? Then we're going to have a write stream. Can't you put a pointer and a length on a U64? Oh, that's kind of funny. You could do that. You're right. You're right. You could do that. I'm not going to do that, but I like that. I like the idea. That's pretty funny. Wasm is 32 bits. Yeah, I think you're right. I think you're right. I'm not going to do that because it feels like too hacky right now, but that is very funny. I like that. I did that on Rust. That makes a lot of sense. That's, yeah, good idea. That's a really good idea. Here we write stream around IO writer. Is that how we do this? I actually can't remember. Okay, this has gotta fucking go, and then we can go to like Zig Street. That's really funny. Zig standard lib. So I try to remember how the JSON serialization API works. Stringify. So I want to stringify to this outstream, and the outstream, is this a just any writer? Yes. Okay. So I have this iWriter, and I say std JSON stringify. I'm just going to stringify the simulation balls into iWriter with options that I like. I don't give a fuck. And so then we should just be able to return state buff like this. And I guess before we just do that, we do like memset state buff 0. I know. What a fucking waste. I understand. But you know, it's fine. It's fine. It doesn't matter. Doesn't matter. Then we should be able to like look for the null on this thing. I guess maybe we don't even need to null terminate if the JSON parser just ends when it sees the correct like end. You know? So let's just see what fucking happens if I try to do that. So if we go over to our test JavaScript. Oh, fuck off. Why is the ad running now? I fucking ran an ad on the hour mark to fucking stop the auto ad from running, but that's annoying. So I just ran an extra ad today for no fucking reason. That's stupid. Sorry, guys. Okay, so here I want to be able to call like state, and let's just like console log the how do I like JSON parse JavaScript? JSON.parse. So can I just do like console log JSON parse this thing, and let's just see if that creates something reasonable. Fuck. CAPI 84 expected this, found that. Okay. That's in C API. This needs to be variable. Right. That makes sense. Makes sense. Okay. So that at least compiled. Now if I refresh this thing and I look here, we see too much recursion at simulation wasm. Interesting. Interesting. Is that coming from this? It is. Interesting. Interesting. Very strange. Stringify max depth, maybe? No. stringify max depth. What does this do? I guess we'll just write stringify max depth and see if that helps. But I don't really see why it would, to be honest. But we'll see. Oh, well, too much recursion, yeah. Too much recursion. Can we maybe zig build, de-optimize, release small? Maybe that will make it so that it's less fucked. Still too much recursion. Interesting. So maybe this stringify max depth is just fucking me. Balls, we have num balls. It shouldn't, like, it seems like we shouldn't be recursing that much, to be honest. But we can just try doing it ourselves, I guess. So let's try, what happens if we do like write stream around IO writer? And let's just do the simple thing first. Of the simple thing is just to write out like begin array and end array. Right? And let's just do this and see if we can at least get that out to our parent. We don't need to release small here. We can just build again. And we are missing something at 84. Oh, expected 2 arguments. What are the 2 arguments? It's options. Fine. Okay. If I refresh here. Too much recursion. Just like even with just this. What the fuck? What if we like take out the JSON writer entirely? And we do like IO writer, write all, and like just write this. Did you figure out the infinite recursion? Infinite adds you at the last 80 minutes? No. No, I did not. No, I did not. It's very strange. Even just like maybe IO writer is too much. Like if we just do state buff 0 to 2 is equal to this. Oh, we have to, it's a mem copy, I guess. Like, is this allowed? Am I just like not where I think I am? It could be that. Like, let's just not call step. Like, oh, maybe it's... Okay, yeah, let's try this, like you said. Get rid of the JSON parse. Although I don't feel like that should matter. That's very interesting, though. That is changing it. That is changing it. So here, we can probably try going back to this. And the value was simulation balls. And then let's turn back on null termination. And let's go back over to the C of the JavaScript side of things. And we'll try running this state function. State pointer is equal to this. And we will basically just say that we're going to state pointer dot. I guess we want like a new uint8 array of simulation instance exports memory. Can you do like as long as we want? Or maybe we know there's going to be 4096. We know that. So we can just do that. We can hardcode that. State array find index of 0. So const jslen is this. And then we can say like state array slice from 0 to jslen. And can we do like JSON parse this? Like, is that legal? This is a lot of guessing, which never goes well for JavaScript, but we can try. 0 is not a function at 172. Find index takes into predicate. Oh. uint8 array find index of value of value. That's not what I want. uint8 array find null terminator. What the fuck is this? What the fuck? I don't think that's what I want though. Uint8 array find value. Index of 0. That's why. Oh, is it index? Fuck off. Okay, thank you. That sounds right. We'll try it. Because you probably know more than me. Okay. JSON expected end of data at line 1, column 1 of the JSON data. And we didn't find it. So can we like maybe at least like console log jslen? So hopefully this is at least doing something sane. -1, not good. Buffer. Simulation instance exports memory. Dot buffer. Fuck. Fuck. Everywhere we use memory, we have to say memory.buffer, which we did everywhere else, so we're chilling. Okay, we got a length of 2 there. That's good. Unexpected non-whitespace character after JSON data, line 1, column 3. So here, why is this not working? JSON parse uint8 array. I guess maybe this is buffer from data as array to string utf. Fuck off. So what was like the text encoder? We've already done this. It's this. So let's at least try this. We text decode the state array slice from 0 to jslen. And let's log the string. Fuck. Why did that change? Oh, okay, I see. We just did, we weren't, the compiling wasn't working before, and that's okay. Okay, refresh. He does some stuff. Okay, wait, that's good. We have our data out. That's very good for us. So now we should be able to JSON parse that. I don't know why it takes so long. I don't know what it's doing here. It's like, its initialization is slow as fuck. But this is, okay, wait, that's really good. That's really good. So now we can actually, basically in our render loop of our canvas now, instead of doing this, we should be able to say, okay, we have balls here. So we're going to skip this load chamber thing. And we're just going to say balls is equal to whatever the fuck we did here. So we're going to just put this in a function here. We're going to say function get balls. Boom. And this is just return this guy, baby. balls is equal to get balls. And then here we just use balls directly. Do I mean balls? Do I mean ball? No, I mean balls. Var balls. Let balls. Const balls. That sounds right. Okay, so this render function should actually work, maybe? We have to be careful that we actually want to do all of this initialization stuff before we try to render one time. So this has to come up here. Or I guess chamber in it has to come down here. That makes more sense. Okay, let's try that. Refresh. Oh, wait. Wait, that's crazy. Wait, that might actually be working. Wait a second. No way. No way. Okay, wait. This is good. Oh, this is sick. This is sick. Okay, so we just need to make sure that we're actually stepping the simulation. So here, every render cycle, let's simulation step. Oh, baby. That'll be sick if that works. We don't need to build there, actually. Now nothing is fucking happening. That's not good. Not good at all. Console log stepping. Refresh. Too much recursion. So it's in the step function that has too much recursion? Let's see. Okay, so we can look at physics. No, simulation C API. Simulation step. Can we maybe like start just like stood log error high? I know this is not good, but shut the fuck up. Step chamber. Collision. History. Done. Okay, let's just see what happens if we start throwing some logs around. High, step chamber. Oh, that's interesting. So chamber mod step is recursing, and it's causing too much recursion. What the fuck are we doing wrong there? So let's go back to simulation C API. Did we just fuck up our step function here? Step chamber calls c.step. And if we go into, oh, we're just idiots. In our test.js, is our glue code just like fucking broken? Step. Chamber step? He calls chamber step? And that's it, right? So it seems like it should be fine. He looks at he gets the balls memory, calls step. So why is it recursing? Because here we don't call anything in simulation. I feel like I'm high. I feel like step is calling itself somewhere. It does feel that way, right? But like, why? Why? Because here we're calling C step, we're calling step chamber. Can we like... Okay. Stood deep log error stepping chamber. Done stepping chamber. Do you have any solid interval code going as well? I do. But I didn't think that would be it. But yeah, you are right that maybe the set interval is causing some issues as well. So let's index.js and let's set interval. No, it's a test.js. Set timeout. Let's just like at least get rid of this and just run it one time and see. Yeah, so we're just saying high, step chamber, stepping chamber, never finishing stepping the chamber. So I feel like I'm high. Platforms. No. What are we on? Simulation CAPI. He's calling step. I mean, it must just be this like name collision, right? This just must be fucking us in some way. Like, I just don't see any other way around it, but we'll see. So if we go into index or test.js and we look at the step implementation on this side, can we at the very least console log stepping here? So we'll call this JS stepping. And then down here, can we be like chamber stepping? And then down here be like chamber step done? Like, what the fuck am I missing? I guess there's no compiling to be done there. High step chamber, stepping chamber, high step chamber, stepping chamber. Yeah, so this is not calling this function. So this is just not going to the right place, I guess. So we'll call this step chamber, I guess. And then our import object will be called step chamber. We'll see if that looks any better. It would suck if that name collision is like a major problem, but yeah, that does just work now, because now he's just going into the JavaScript immediately. So it does look like there's just like fucking name collision. Is it, I guess like probably it's something silly like they had different APIs but the same name, and so because they were both expecting like C export and import functions, the linker resolved them to be like the same thing or something. So there's like a foot gun in there that I should just be careful for. Like the fact that I put it into like a C struct to avoid the name collision is actually bad, I guess. But it makes sense. Like, I kind of get it. It's just silly. Test.js 141. So what am I doing wrong here? Out of range. Out of range. So let's console log chamber dest byte len. Let's just see why it's fucking freaking the fuck out. -4. That's not good. -4. That's really not good. What was his balls memory? Return. Oh no. Almost seems like a bug. Making it, you might want to open an issue if you can make a simple repo for it. Maybe. Yeah, I'll take a look. I'm not really convinced that it's like actually a bug. But it could be. Okay, so what am I returning here? Balls memory, hello? Why is this not... Oh, do I need to put a new line on here? I don't think I do. Why is this balls memory not fucking... Hello? What chamber am I loading? Platforms wasm. Do I need to fucking control F5? No? Am I fucking... Stood log error. Oh no, I do want to print here. I feel like there's like some catching going on that shouldn't be. Can I in init say like initing? Like, there's just something fucking fucky going on here. Yeah, this is just doing something wrong. Is it possible that like my Python server has cached something that it shouldn't have? Oh, we're just not. I'm stupid. I'm stupid. There's no printing in the chamber because we didn't implement it. So we'll just call this log wasm chamber. Then here we can just say this comes from chamber and it's all the same after that. Okay. Refresh. Log wasm is not defined. Okay. So this would be log wasm chamber like this. I don't actually have to. Canvas memory right here. Here we go. That's good. So why am I not getting balls memory anywhere? Oh! Am I not calling init on the chamber? I probably am not. Oh wait, but I'm calling it here. So here we should be able to go into platforms, Zay, and on init. We should see initing. Okay. But I don't see that. Print, hello Mick, I am really initing right now for real. Yeah, I don't see that anywhere in here. Which could explain why it's just fucking wrong, because I need to, the wasm allocator just doesn't run, and this like balls thing is undefined. If I write this as like 100, this doesn't change, which is interesting. Oh, because that didn't compile, obviously. Obviously. Let's clear cache just to like, just for peace of mind, even though I don't like think that the zig cache is doing anything wrong, I just want like the peace of mind out of it. We're so close, man. It feels so close. So, the fact that it's logging canvas memory is so strange to me. But not balls memory? Like, what the fuck is the difference? You know? Console log init chamber called. Let's just make sure that this is called. If that's not called, then we have like a big problem. Init chamber called. Then he says all good in the hood. Chamber instance exports init. Is this before chamber is valid? No, chamber's been set here. So why the fuck is this just not running? Like, what the fuck am I missing? Chamber instance exports, like canvas, like this is running fine. Oh, this is running again, which is probably bad. Although that doesn't really explain the problem. Init chamber finished. Like, am I just like fucking... Init chamber called, init chamber finished. So why the fuck is my platforms zig? I have a fucking log in here. In init, right? Hello, Mick, I'm really initing for real. Like, that's not getting printed. Why the fuck not? Name collision like in step, but they're like namespace now, like they should be. I mean, that's something to like, it's definitely something to worry about, but I don't understand. I more wonder if, I mean, the fact that I'm not seeing the chamber in here is a little concerning. Like when I run this, I feel like I should be seeing zig out bin platforms wasm here. But I'm not. Can I like clear cache? Network, disable cache. Now I'm seeing platforms wasm. And now I am seeing hello Mick, I'm really ending right now. So I don't know why that's happening. Which is fucking annoying, but it's fine. So this is a good sign to some extent. I don't see any like major exceptions in here. Did we call step in here? We did, and let's now also just call this in a loop. Wait, I did see movement there? A little bit of movement? That's really good. But then it's crashing for whatever reason. So this is in render at test.js 82. So this step is indirect call to null. That's weird. Runtime error, indirect call to null. So this is working like 10 times over. What is this call stack? Like, it's set timeout. This shouldn't be like adding, this shouldn't be like Stack Overflowing or anything, right? It's very strange to me that this works for a little bit and then just stops working. Very strange indeed. Very, very, very strange. Okay, I think this stuff can go away. What am I missing? What am I missing? Like, the fact that this is saying runtime error, indirect call to null. Oh, this is coming from within simulation wasm, though. Oh, I bet that this is the history writer. Yeah. Hold on. I think I actually know what it is. It's in physics, C API, simulation C API. I think that these undefined things are just fucked. So here we want to change this to load and save chamber and save chamber. And we'll just stuff them out. So this will be load chamber. And we'll just fucking do jack shit. And save chamber. We'll just do jack shit. We need a buffer. Probably on both. I think one of them takes an allocator as well, actually. I think. Okay, let's try that. Close. Save chamber takes allocator and returns the U8 array. Right, so this is more like this. And then we need, it's like, what the fuck, I can't do that, so we'll just write return nothing. Okay. Then we can try refreshing here. It's working! Wait, that's so fucking sick! Oh, it even bounced off the platform! I mean, it's running slow as shit, because we're supposed to be running this 60 times a second. So we can just do this instead. We can go into test.js and we can look at the where we call step. And we can say that our window timeout. Here we should every 16 milliseconds we'll just run it 60 times. So for int I equals 0, or let I equals 0, I is less than 60, I plus plus. I think that this should do what we want it to do. Run at 60 frames per second. A little too fast. So this is probably like more like 20. Hell fucking yeah, man. Okay, that's super sick. That's actually so fucking cool. So this is the exact same simulation that's running on the server, is now running like completely in the client. Reset isn't hooked up, but that's super sick. That's actually super fucking cool. Okay. I have like shit to do. I have somewhere to be at 5 and I have to like walk my dog and stuff, so I have to call it right now. But thanks for watching, guys. If you liked what you saw, we stream most days at around 2 o'clock Pacific time for around 2 hours. So it's 4 o'clock Pacific time right now. If you are new here, there's a YouTube link in the Twitch description where all of our stuff is broken up to playlists, so you can check out like stuff we worked in the past, operating system, terminal emulator, QR code decoder, video editor. There's stuff in there if you want to check it out. There's also a GitHub link in the Twitch description if you want to check out the code associated with all of these projects. If you're watching on YouTube, there's a Twitch link in the YouTube description where you can swing by and say hi if you're online between 2 and 4. We also have started doing this pre-stream thing recently, so sometime maybe like 12:30 or 1, we kind of work on the stuff that it's like, the mainstream is kind of focused on like feature development, new things, trying to make like rapid progress and make something that makes like a title and thumbnail that's like interesting to watch, right? But the pre-stream is kind of more like vibes focused and like kind of more about like, you know, right now, if we were to just leave this as it is, we would not be able to fucking continue working, right? So there's a lot of work that has to go on after this to make sure that like, oh, all of the code is like in a good committable state. We didn't break everything else. You know, it's not just like test prototype code everywhere. So the pre-stream is kind of more about trying to figure that stuff out. So if you want to check that out, you can come swing by on Twitch, or there's a Patreon link in both the Twitch and YouTube descriptions where you can see VODs of that thing. I think that is all we have to plug. Thank you for watching. Goodbye, YouTube, and Twitch. Let's figure who to raid.